Okay, so today we're going to be looking at a differentials problem from the 2023 test 3 for Math130, and it says this person purchases a frisbee, which is a solid circular disc, to throw with his friends on the beach. He measures the radius of the circle to be 20 centimeters. So here's my circle with a radius of 20 centimeters. Okay, and it says when he measures that radius, it has a maximum possible error of 0.2 centimeters. So we can look at a maximum possible error as a small change in the radius. So let's say that the change in my radius is 0.2 centimeters. And we can also rewrite this as 2 over 10. Okay, cool. So A says, use differentials to determine the maximum possible error in the calculated area A of the circle. So let's write A, our area of the circle. And we know the area of a circle is just pi r squared. So again, we can look at a maximum possible error as a small change. So they want us to use differentials to determine the small change in the calculated area with respect to the small change in the calculated radius. So firstly, I'm going to take the derivative of both sides with respect to r. So d by dr of my left hand side is equal to d by dr of pi r squared. And we get dA over dr is going to be equal to 2 pi r. So what does dA over dr mean? Well, this means that how fast is the area changing as the radius changes. So how do we change this into a differential? Well, I can multiply both sides by dr, which will give me dA is equal to 2 pi r, multiplied by dr. And again, this is a rate of change, which means how fast A is changing, or my area, with respect to my radius, so as my radius is changing. Now, when we converted it into a differential, this means that a small change in the area, and this means a small change in the radius. So we already have what we want in the question, which is a small change in the area. So this is going to be equal to 2 pi, and our radius was calculated to be 20, multiplied by our small change in the radius, which is 2 over 10. And simplifying further, multiplying that in, we get 40 pi multiplied by 2 over 10. Simplifying even further, multiplying 40 by 2, we get 80 pi divided by 10, and that's going to be equal to 8 pi centimeters, and don't forget the squared because of area. So our maximum possible error in the calculated area with respect to the maximum possible error in the radius is 8 pi centimeters squared. So moving on to B. And B says, hence, determine the percentage error in the calculated area A. So using the formula, which is dA divided by A multiplied by 100 to get a percentage, and substituting, here we have our dA, and here we have our A, So subbing that in, I'm going to have 2 pi r multiplied by dr all over pi r squared times 100. And if I simplify this, I can notice that I have a pi r on the numerator and the denominator. And before I put dr down, let's not forget that dr is 2 over 10. Factor out a pi r from the denominator. And let's cancel these out. Let's multiply 2 by 2 and we get 4 over 10 all over. Our radius was calculated to be 20 and multiplied by 100. Okay, multiplying in here by 100, I will have that 400 divided by 10, which will just give me 40, and again all over 20. And simplifying once more, we get 2%. So our percentage error in the calculated area A is 2%. And that was differential word problems made easy.